Hi, my name's Sean Perry. This is video number 39 in the series, Factoring by Grouping. So factoring by grouping is a technique to factor a polynomial, that is, to write a polynomial as a product of polynomials, which uses repeated factoring out of the greatest common factor, which we looked at in the last video. We will use factoring by grouping to factor certain cubic polynomials which have 4 terms, such as x cubed plus x squared plus x plus 1. But we'll also look at how this comes up in the discussion of factoring quadratic trinomials. Quadratic meaning it has degree 2, and trinomials meaning there are 3 terms. The trick is to write things as having 4 terms and then cut it in half. We'll look at how to do that with the trinomials in a second. But for the first example, let's look at the cubic. If we have 4 terms, we can look at the first half and the second half and ask what's the greatest common factor. The greatest common factor of these first two, x cubed and x squared, is x squared. We can factor x squared out of both. And x plus 1, well, no common variable terms, and it's just a 1 and a 1 coefficient, so really the greatest thing we can factor out is just 1. Writing things this way, what we notice is that there is a common x plus 1 in both the first term now and the second term. Since we have x plus 1 repeating, we can now use the distributive property again to factor it out. And doing so looks like this. Instead of x squared times x plus 1 times x plus 1, we now have x squared plus 1 times x plus 1. So we have factored the polynomial. It is now written as a product, and we would therefore consider it factored. If you want to check this, you can FOIL this back out and make sure that you get the original polynomial. Here's a slightly spicier example. Let's look at 2x cubed minus 3x squared minus 10x plus 15. Again, we want to cut this in half and factor the greatest common factor from each half. Doing so looks like this. Notice that there is only a greatest common factor of 1 for the coefficients, but I can factor out x squared from both of these. Moreover, with 10 and 15, I can't factor an x out, but I can factor a 5. That looks like this. Now, we're sort of in a different boat because these two don't exactly look alike, but they do look close to each other. I mean, one is just the negative of the other. One has the opposite signs as the other one does. So what if instead of a 5, we factored out a negative sign too, a negative 5? We usually think about greatest common factor with positive numbers, but here's a situation where we might want to consider the negatives too. If I do that, what I wind up instead is 2x minus 3 and another 2x minus 3. And since we have matching now, we can factor out this common term. That gives us x squared and minus 5 in its own term, and 2x minus 3 gets pulled out into the second term. We've written the polynomial as a product, so we've factored. This is a good time for some critical notes. Copy this down, show it to me later so I know you watched the video. How do you do factoring by grouping? You cut the 4 terms in half and look at the first and the second half separately. Factoring out the greatest common factor from each half, we then look for matching terms. Once we do that, we can pull out the common term to each half and write it outside of another parenthesis, which encapsulates the 2 terms that the common term was multiplied by. Now, does factoring by grouping always work? No, I mean, not every cubic has 4 terms. Not even every cubic with 4 terms can be factored this way. But if you're given a cubic equation, it's a good first attack to try to see if you can factor it by grouping. Another example of how we can use factoring by grouping involves quadratic trinomials. Now, let's consider one we've already factored. Here I have x plus 3 times x plus 2. And if we FOIL that, we get x squared plus 2x plus 3x plus 6. And I want you to notice that we could combine the 2x and the 3x by like terms. But before we do, let's note that if we have something that looks like this, still expanded, still without contracting the like terms, we could use factoring by grouping on these 4 terms. Let's see what that would look like. So cutting it in half, factoring the greatest common factor from the first part, which is x. There's an x I can take out of each. And the greatest common factor in the second part is 3. I get x times x plus 2 plus 3 times x plus 2. And that gives us this common x plus 2 as a common term, as a term which is common to both of them. That gives us x plus 2 as a term which is common to both of them. And so it can be factored out. We write the x plus 3 up front, and we times that by 1 x plus 2. And we've recovered the original factored state using factoring by grouping. Let's look at another spicier example. Let's look at one with bigger numbers. What happens when I FOIL this? So take this polynomial, try to FOIL it yourself, and see if you got this. Notice that yes, we could contract this to 7x, but before we do, I want you to see that we could factor this by grouping and recover the original polynomials. So we will look in the next video about what's the right way to break this middle term, in this case it would be 7x, to break that into a 15 and a minus 8. We'll see why that's the right way to do it and how we can decide on those terms once we look at factoring general trinomials. But for right now, I just want you to see that once we have those two terms, we could split it in half, take the first two, divide out the greatest common factor of 3x, take the greatest common factor from this and divide out a 2. Actually, let's take a look. We want this to match, so we're going to want to divide out negative 2. And if I do that, we wind up with a 4x plus 5 in both places. 4x plus 5 can then be factored back out, and we've recovered the original polynomial. Here's some practice exercises. Pause the video at this time and give each one of these a shot. Okay, let's see how you did. So the first one, we cut it in half. We factor out the greatest common factor from both halves. Here that's 2x, here that's 3. And then we factor the common term out of both of those and bring it up here and write the 2x squared plus 3 in its own term. Here's the second one. Again, we cut it in half. We factor out the greatest common factor from each half. Then we factor out the common term, and we're done. Here's number 3. We have this trinomial, or it would be a trinomial if we collected like terms. As it is, let's try factoring each half, factoring the greatest common factor out of each. We get matching if we pull out a negative 3, and then that matched common term can be brought out itself. Done. Here's the final example. If I cut this in half, factor the greatest common factor from each half, and then factor the matching term out of each, I get my final answer. That's it for this particular video. Thank you for your patience and have a great day. I'll see you in the next one. Good luck with your studies.